morning, everybody, and welcome to the Mission Horizon Headed to the Moon Coaches Meeting. I hope everybody's wide awake, got your cup of coffee and ready to go. We're going to go over some different aspects of the challenge this year, but first I want to start off with some promotional ideas. As you saw, my little Pokemon guy was wearing my RCX t-shirt. We've got plenty of t-shirts and other items on the website that you guys can purchase for yourself or your students. We will be putting out there the shirt for the Headed to the Moon, or Mission Horizon Headed to the Moon Challenge. It is available for sale now and will be sent out in late January, early February in time for the regional tournaments. The other thing is, if we can pan down a little bit, coaches over the years have asked me for a competition board that was easy to use, easy to assemble. So this board is a corrugated plastic. It weighs less than 10 pounds. The mat fits perfectly inside of it. So teachers who don't have the ability to set up the board and leave it up permanently have the ability to use this board and pick it up and move it. And so right now I'm just going to imagine I'm at practice and it's the end of the day. I'm going to take my mat. I'm going to pick it up. I would do a better folding job. I would roll it up. But I'm going to take this and set the mat away. And then I'm going to take my support. If you notice on the front of the there's some wooden frame. That is what holds it together. There's 4 pieces of wood that we can take apart rather easily. My table here that I'm using this on is about 6 inches too small. So it comes with 4 boards that are basically the exoskeleton of the board. And so you've got these 4 boards that create the frame. We can take them and we're going to put them to the side. Guess we're going to put them in a storage closet or something like that for you at school. And then we're going to fold up the board. And it's just plastic. See how small it is? It's really light. And we can put that away in the storage closet as well. And literally, within a minute, you can have the competition board, or at least the plastic practice board, put away. That is available on the website for purchase as well, if any of the teachers would like to have that. It is $250. It is kind of expensive, but it is easy for the teachers, the students, to be able to take the board, the practice area, and put it in the closet until the next practice, which for some schools practice may be the next day, other schools practice may be next week. So again, it's something that teachers have been asking for, and I found it for you guys, and hopefully you guys can take advantage of it if you wish to have the practice board. All right, now let's go to the main purpose of this, and that is the coaches meeting for the Mission Horizon Headed to the Moon Challenge. Now I've got my mat set up already, and the table I'm using is about 6 inches too small. So on the practice board, the competition board, it will be fit in there perfectly, be level and whatnot. But just for today, you may see that the mat is kind of creased in a couple spots. So when you open up the box that I shipped to you, you got the competition mat, you got some dual lock, and either assembled or under assembled, you have 2 or maybe 3 sets or bags of Legos. The unassembled set, the mission object instructions, the video is currently posted for the students to assemble them. But these are the items, the 4 items you see in front of you are the items that you should have received in the box for what you purchased. All right, let me get those out of the way. The next thing, I've assembled all these mission objects, but for many of them, they need to be dual locked down. And so to make things simple, I'm going to dump all these pieces out because they're going to go around the board. But as I'm talking, we're going to set up the tank farm here with the dual lock. Now the hydrogen tank will not be located there, it will be located in the safe zone, so we need to find the oxygen tank and the water tank. Okay, and what we're going to do is we're just going to dual lock those 2 in place. Anywhere on the mat you see the initials D and L, you'll have to take a section of the dual lock and dual lock those items down. So almost half the items we have for this year's challenge require dual lock. So as we go through the mat today and discuss it, again, I'm just going to dual lock these 2 objects, but you guys will have to dual lock all of them. So what I'm doing here now is I got one piece of dual lock, a top and bottom, and I'm just going to put the oxygen tank on top of it so it sticks. I've got another piece of dual lock, top and bottom. I'm going to peel off the back. Okay, I can never do this when it's in the moment. All right, probably should give this to my photographer. She could probably get it done in no time. But anyway, we'll peel this off. Maybe I won't peel it off, maybe I'm not. Alright, there we go. Peel off the first side, stick it on there. Then we'll peel off the second side. And we'll put the water tank in place. Just like that. Alright, so we've got the oxygen tank and the water tank. Both of them are dual locked in place. Now I'm going to go around the board and I'm going to pan clockwise around the board for those items that need to be dual locked. So notice that the generator, it's got these 2 little nubs sticking out. We're going to dual lock that in place so that the nubs look at the south wall. Okay. The next one we have to dual lock will be the solar panel. We're going to put the solar panel in place here. The next ones we're going to do will be the markers, and there's 2 of them. The first one is right in front here. The second one, I've got stuff in the way, is up here on top. And we'll dual lock both of them in place. Notice that the flag on the marker, it may be moved. Okay, so the angle of the flag when you go to the tournament may be in any direction. All right. The next object we're going to do is the silicone storage, and we're going to dual lock these in place. The next one we'll do is the meteor shift, and the first one will come over here, and the second one over here. All right. Now we're going to go to the front, and we've got our habitat area, which will get dual locked here. And just so you know, this blue size is what is it, 16 by 16. You can make something smaller if you wish, and this one is a 12 by 14, I believe it is. If you make something smaller, we attach the smaller one just like that, so that the smaller ones start with this top left corner. Attach them here. At the competition, the regional host will have dual lock all the way around for smaller ones. but ideally the blue one is the size that I'm recommending. You should not go larger than this dimension. There is a document, the Habitat Mission 1 document, that explains these in detail. It also explains the requirements for the students in Mission 1. Okay, but just know we're going to dual lock that one there, just like that. The next object will be the satellite dish. And the satellite dish should be positioned over it, and the angle of the yellow axle should face the middle of the mat. So if for some reason the angle of the axle is this way, or this way, that is incorrect. For the tournament, it will be facing this way, so that as the kids prepare, that is the angle, and it should not create any obstacle other than that direction for the students to attempt the Habitat mission. All right. The next object we're going to dual lock down is the iron storage hopper. All right, and now the iron storage hopper is placed up here on top, just as so. Okay, so what I want to do is I'm going to talk to you, because everybody knows I love to talk, and as I'm talking I want to try to place the mission objects in the correct location, so that way we can get things started. And I'll explain all the mission objects. Okay, so this year's challenge, as you're going through this year's challenge, I spent a lot of time doing research. I'm kind of a SpaceX junkie, where I follow SpaceX and the things it does. And so preparing for this over the summer, I took a trip to NASA's Kennedy Space Center, got some research down there, been doing a lot of stuff on the website with Blue Origin, Sierra Space, Icon, which is a 3D printer style home builder that's going to build homes from materials on the moon. You have some legacy companies that are involved with NASA. NASA's got their Artemis program, which is their second attempt to go to the moon and establish a colony. There's a lot of details as far as what they're going to do, what companies are trying to do. But it's just, there's a bunch of links there that students can be inspired for the next generation to get Americans back to the moon. I know in the 1960s we were trying to get there before Russia, but today space exploration has gone into the private sector. Internationally, China, India, European Union have all done stuff to get to the moon. So many of the companies and countries are collaborating to get there, and SpaceX is in the forefront of trying to get to the moon and actually to Mars. So check those links out, have your students check those links out. There's a lot of information that the kids can learn about past space exploration with satellites, rovers on Mars. They just sent up a rocket to Jupiter 2 weeks ago. So it's that kind of thing that there's a lot of stuff that the kids can learn from. But now that I've got this table set up, we're going to start in the safe zone, and I'm just going to explain the mission objects. So first off, each team received an astronaut in the kit. The astronaut is needed for mission 13, so the teams do have to bring their own astronaut to the competition. If by some reason your astronaut goes on vacation and you can't find him, any minifig will do for the competition. We have, to your right there, we have the Cargo 2. We have 4 silicon pieces. We have the hydrogen tank. We have the rocket, and I'll explain a little more about the rocket and the exploration vehicle. And one of the things about the exploration vehicle, if you go to NASA's website and look up the rovers have different arms and attachments and sensors. And all these little things here are intended to represent what the rover will be able to do on the planet. And essentially it will be able to do research autonomously out there on the moon, find minerals for us to explore, primarily hydrogen. If we find hydrogen, we have a source for life, whether it's energy, sustenance, but hydrogen, we can get frozen ice, take the water and separate it out, take the oxygen, separate it out, and the hydrogen, separate it out, so that we can establish the colony. So, but that's our exploration vehicle or rover there. Now we're going to pan to your left, and we'll just explain first. You'll notice names like Shackleton. That's where NASA wants to find ice. And there are other names like Shoemaker, DeGalarche, I'm going to probably ruin that one, Hayworth, and others. These are all craters that have importance for NASA. So just know, part of the research, these craters do have value beyond just names on this map. We have our first touch penalty, or rock number 3. We have our tank farm with the black ring and the red ring. We have our exploration marker, which is dual lock down. We have our generator, which will likely be powered by hydrogen. We have another rock or touch penalty, number 1. We have our moon shuttle. And imagine a drone today that you're trying to develop to fly packages or whatnot, and possibly even people around Earth. We're going to have our moon shuttle, which will probably be like a drone type taxi cab going around the moon. We've got our solar panel right here. The quad platform up top is going to be called Quad Crater for this challenge. So we do have a couple missions going there. And then as we go to the right, we've got our meteor shift. Let's put this in the right direction. Okay, coming over, we've got rock, or touch penalty number 2, silicone storage, followed by the exploration marker. We now have our iron storage hopper, and there are 4 pieces that you have to recover. And this is probably the one I should have dual locked down, because I'm going to do stuff with it. But they will be inside the hopper at the start of the match. We have our rock, or touch penalty number 4. We have our truck, and we have our truck cargo. And this will actually be located in the truck at the start of the match. We have our landing zone with the red ring. I'll explain that later. We've got rock number 5, and then we have our airlock. The airlock will be attached to the habitat base, and you will design this with your students. Again, the document Mission 1 Habitat will explain in detail what you have to do, but the airlock fits in just like that. Okay. All right. Now we will start by saying there are several documents for you to consider. We've got I had an email this morning about this. The mission object videos, the construction of them. We also have the mission objects headed to the moon, mission objects starting and scoring position. So this is like a 15-20 page document that shows you where the mission object starts and how it scores. So we just ran around the board and explained where everything is, but this document has pictures, mission object by mission object, that will show you where it starts, how it starts, and how it scores. This is just one that just gives you a brief outline of the mat overall. So it's just the Mission Horizon Headed to the Moon mat. The next one I got here, there's a practice score sheet on the website. So many teachers use that as the ability for the kids to monitor how they're performing. I've mentioned this a couple times already, the habitat document. So basically Icon and Sierra Space are both doing habitats. Again, Icon is doing a 3D printer. Sierra Space is doing an inflatable. So basically imagine a rocket going up that's a cube, 3x3 cube, and you get up there and all of a sudden it expands into a cube that is now 10 by 10 by 10. So it's designed for space, like the space station kind of, but it can be used as a capsule on the surface of the moon. And this habitat is 15 pages of things and options that the teams can do. Now, I put this out there a week ago, and the first question I got was from a teacher. I ordered one set, but I have multiple teams. So, first thing, you're going to take your base and you're going to incorporate it in the design of your habitat. Second, you have the ability to take and recreate the base. So if you have multiple teams and multiple bases, there's instructions on how to build with pieces from your own inventory, how to build for your second team or your third team. Whether it be how to attach it to the walls or how to attach the airlock. Okay, because most of the pieces that are in here, the color may be different, but over the last couple years, those pieces have been included in other challenges. So, and then the last document I have for us today is the missions and rules for the Headed to the Moon challenge. And that's what we're going to go over for the rest of this video. Okay, so the first rule change is the first page, rule changes. Rule 2, robot limitations. Historically, it has been a Lego NXT Mindstorm Spike Prime based robot. Well, Wonder has the Dash robot, which has an autonomous function. It has Lego compatibility. So if you are using the Dash robot from Wonder, you can use that this year for the challenge in the autonomous mode. Okay, there are some other changes that we have done in the past also listed there. We have just an outline of the mat again, some tips on as you read through for you and your students to be aware of words like in, on, above. Those words have meaning, and the students need to be aware that when the mission says put something in it, and it has to be in it. And in order to be in it, the referee looks from above, looks down, and sees if it's in the parameters of the object. And if it's in it, you get credit. If it is not in it, you do not. A big word also is the word touch. If a mission object has to touch the surface, touch the mat, touch the quad, if you deliver it to its destination but the object is not touching, you do not get a score. So make sure that if the mission states touch, make sure the mission object touches.
Somebody wants to know if these forms are already on the website.
So all the forms that I've just listed are linked on the Mission Horizon mission and rules page. So everything we've gone over. Other than the documents I've stated, this video will get linked there later today. If you have a need for something, explanation or something, I'll either create a video or a document to help in the future. But the documents that are linked there today will be the only documents I create unless you guys ask for some additional documents. Okay. All right, so this year's challenge consists of 13 missions. with a total point value of 800 points. When we go through this, I was thinking some of these missions are rather easy, and some of the missions are rather high point value. But when I started to break down the programming or the construction of the robot or the attachment, the value of these missions is elevated because many times the kids are being asked to do 2 or 3 things to accomplish a mission. Distance from the safe zone is a problem, but also I have to consider, and the kids have to consider, does the robot have to turn? Does the robot have to have an arm lift or lower? Does the robot have to return to the safe zone with an object? So many times these point values are assigned because of the distance from the safe zone, the action the robot has to do, and the programming that the kids, I perceive, are going to have to do to accomplish these things. So when you look at this, sometimes in the past there's been more missions for the kids to attempt, but this year there's fewer missions, but the missions that are there are harder. And again, I brought up about the words "and on touch." The kids really have to strategize how they're going to do these missions, kind of like a chess match against the opponent. You can say checkers, but a chess match is more how I look at it, because when you have a robot run, do you have the kids do one mission at a time, or do you strategize and have the kids do multiple missions with one robot run? And I recommend multiple missions per run, but that's part of how these point values are assigned, is that I'm looking at what the kids are going to do, how the kids are going to construct and program the robot, and hopefully they have the ability to attempt 2, 3, and maybe 4 missions with each robot run. Okay, so let's now get into the actual mission and rules document. And the first thing that you're going to come to is it's going to say, I can't read upside down, but each mission has the letter P or C behind it. The letter P means partially, the letter C means completely. So as the kids attempt, or as the kids read a mission and they notice the P or the C behind the mission statement, just know that they get scoring credit for whether it's a P or a C. It's outlined mission by mission, and most of them, if it's partially or completely in the designated area, they get full credit. There are a couple missions that the object has to be completely in, but just know that for the most part, the scores are awarded for being partially in an area or completely in the area. The value is the same. Okay? All right. So that's the P and the C clarification. The next thing is the touch penalties, or the rocks. And again, there's 5 of them. And we went over where they are. In front of us, we've got number 3. To your left is number 2. And to the far left is number 1. 4 and 5. Here's number 4 and number 5. So where those rocks rest, right now they are worth 5 points. If the team does nothing and just leaves them rocks where they are, they get 5 points per rock for a total of 25 points, assuming that they sit there and the match is over and the referee starts tabulating the scores. They get 5 points for each one left on the board. Okay? Now, the next part is probably if the team is able to take all 5, and I'm just going to grab them real quick and put all 5 in the safe zone, they now become worth 15 points each for a total of 75. And these are all in the safe zone. So to help out with what in the safe zone means, when we do a quick demonstration, we move 5 rocks. The rock on your right is completely in, 15 points. Rock on your next one is in completely, 15 points. The rock in the middle is partially in. Notice how it's half on the black line, half outside, so it's partially in. They get full credit, 15 points. This rock here is not in the safe zone, but it is on the mat. It's worth 5 points, as well as this one. This rock is not in the safe zone, it's on the mat, it's worth 5 points. Okay, so in this scenario, we have 15 plus 15 plus 15 plus 5 plus 5 for a grand total of 55 points. Okay, now I'm going to set these back out here where they started, and we're going to discuss the touch penalty and how the referee will assess touch penalties. So students, as the robot runs across the mat, the robot may have a little attitude where it doesn't do what the kids expect. So if the kids program the robot leaves the safe zone, goes out on the mat somewhere, and then the kids touch the robot. That's a touch penalty. So each time the kids touch the robot, several things happen. First, the referee says touch penalty. The student needs to grab the robot and take it back to the safe zone and start over. If the robot was controlling, let's just say the robot for whatever reason had the hydrogen tank in it, and the robot is in this area, the referee says touch penalty, the students take the robot back, but the hydrogen tank stays in the area that the referee noticed the touch. So the students cannot take mission objects back with them. The mission object has to stay roughly in the area it was when the touch penalty was assessed. So if your students have been assessed a touch penalty and the referee leaves the hydrogen here, practice with your students to run that mission again and grab the hydrogen to continue on its way to the tank for them. So many times students get confused with touch penalties. Just know that the robot restarts in the safe zone, the mission objects stay out on the mat, have your students rerun the same mission, and many times the robot will capture that object with that subsequent mission. Okay. So first off, the referee has said touch penalty. Second, the students have taken the robot back to the safe zone. Third, the mission object stays on the mat where it was touched. Fourth, the referee now takes one of the rocks or touch penalties off the mat. And as we have explained a couple times, they're numbered 1, 2, 3, 4, and 5. The westernmost starts with number 1. Number 2, number 3, number 4, number 5 is the one that's closest to the east. So just know that the referee will take the westernmost rock for the first touch penalty, the second westernmost for the second, the third westernmost, fourth, and fifth westernmost for each touch penalty. And the kids, there's a maximum of 5 touch penalties. If you run the robot and there's a 6th touch, the referee doesn't take anything, the students just reset in the safe zone. So just know that for the first 5 touch penalties, the rocks are taken. The referee will take the rock from anywhere across the mat, and even if the students have put the rocks in the safe zone, the referee will take the rock from the safe zone. There is no safe space for the kids that once they recover a rock, the referee can grab it, whether you got the rock in the safe zone, extension of safe zone, whatever. If you have a touch penalty, the referee will assess a touch penalty. Okay? All right. So I'm just going to put the touch penalties all right there for now. Okay. Now the next mission we're going to discuss is, and these are all outlined in a clockwise fashion. So the next mission, mission 2, is actually processed hydrogen. So, Shackleton Crater is a bunch of ice. And so NASA, their efforts, they're going to go up there and take that ice, process it into oxygen, water, hydrogen, so that we can establish a colony. So, mission 2, take the hydrogen tank from the safe zone, relocate it to the tank form. All right. Now, when you get to the tank form, it has to be in the ring, either the black ring or the red ring, partially or completely. So if it's over here and it's not within a ring, there's no score. If you're able to get the hydrogen tank to cross the black line, it's worth 30 points. If you're able to get it to cross the red line of the red ring, it's worth 45 points. So this mission object may be vertical, maybe on its side, but just know that when it gets into the ring, it receives the point value that's highest. So if it crosses both the black and red, it only gets points for being in the red ring of 45. Okay, there's no compounding or adding on for the black ring plus the red ring. It's just the maximum of 45 points. The next one is mission 3, which is the generator. And the generator, I'm going to take it off its base. But the generator has an orange bar and 2 red lines. So when you set the generator, the orange bar, the orange Lego needs to be above the orange on the outline. Teams will have to rotate the orange Lego to be between the 2 red lines for a score. Okay? And if they are able to get it between the 2 red lines, they receive a score of 50 points. Now, as they rotate this, when it's still locked down, it actually has the ability to spin quicker than expected. So just know that the teams have to approach this in a way that is controlled. Take it. No score, no score, no score, no score, no score. All right. Referee from above looking down. It has crossed the red plane of the red line, barely, but it's crossed it. So now you get a score. Score, 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 score. It's completely in. Score. It's partially in at this point. Oh, it's back outside. So in order for the team to get a score, the point value is 50 points for this. The orange Lego must be between the 2 red lines, either partially or completely, to receive the score. Okay? The moon shuttle is actually mission number 4, but I'm going to come back to that here in a second. We're going to go up to the solar panel. Now, if you do the research, you're going to say, Doug, why do we have a solar panel on the moon? Because we're essentially at the south pole of the moon where there's no sunshine. Temperatures like 400 degrees below zero kind of thing. But it's that kind of thing. Why would you have a solar panel? Well, we're going to assume that at certain times that the sun does shine and the solar panel will be effective for us to generate some power. So if we're doing the solar panel starts at a right angle, so it's vertical. All you have to do is get your robot to partially or completely push it down. You get a score if it's nudged. Score, 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 all the way down, completely down. So just know it's a 35 point value. Just push the solar panel down to receive your 35 points. The next one is explore the crater. So real quick, just take an angle over here. We'll grab our exploration vehicle. And you have to grab this. You can combine the arms, if you wish, to make it kind of smaller, or you can allow the arms to be spread out. This object does roll, but you have to program the robot to deliver the exploration vehicle to the quad crater. All right, and this is the border of the quad crater. the black line, this triangular area. Now there's a wooden board on top, but just know that you're going to get this to go underneath that wooden board. Okay, so if you can get the exploration vehicle to get out there, is worth 45 points, partially or completely. So here's what we're going to do. Right now, no score, no score, no score, no score, no score, no score, no score. As soon as part of it, let's do this backwards. Let's just say our arm is extended out. The tires are touching. No score, no score, no score, no score. Well, our arm is extended out. It's not touching, but the arm is over the black line. So once any part of the exploration vehicle crosses that line, is considered partially in the quad crater. So score, 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 score. All that's a score. As long as it's anywhere across the black line and underneath the board, your team receives a score of 45 points. Okay? All right. So that's scoring the exploration vehicle. Next, I'm going to do the robot and cargo 2. So cargo 2, and this is mission number 7. We're going back to the quad crater. Cargo 2 and your robot. So you're going to take and put cargo 2. The exploration vehicle is underneath the quad platform, which is the wooden board on top. You now have to take cargo 2 and your robot and put them on top of the quad platform. Okay? They must touch. Both objects must touch the top of the quad platform. So if you deliver cargo 2, it can touch. It can touch. It can be partially on, completely on. Same way with the robot, partially or completely, but it must touch the surface. If by some chance, let's just say this object is here, and we put cargo 2 on top of that object, cargo 2 is not touching the surface, you do not get a score for that. So therefore, you have to make sure that when you deliver cargo 2 or your robot, that it touches the surface of the quad platform or the quad crater. Okay? And for that one, you receive a score of 40 points for cargo 2. You receive a score of 85 points for the robot if you can get them to climb and be on top. And there's an additional document linked at the mission. It says scoring the quad platform drive source. That'll explain the robot and what the requirements of the robot being on the surface are. Okay? So we're halfway through here, folks. The next one is clear the way. So clear the way is the meteor shift over here. And you get a score for each object separately. Okay, they can be completely moved or partially moved. But you get a score of 30 points if you move one panel and 45 points if you move 2. So these are both dual lock down. And let's just say you nudge that one, that's a partial move. You get a score of 30 points. And let's say you nudge the second one, you've moved 2 of them. So since you've moved 2, that's 45 points. Whether it's completely all the way down or partially, as long as you move them, you get credit for the score. So if you move 1, it's worth 30 points. If you move 2, it's worth a total of 45 points. All right? The next mission is mission 9, Habitat Materials. So again, the links. Icon is building a 3D printer that can build a house, that can build a habitat. NASA is going to use the materials on the moon to create the habitat. So Icon is basically taking the dirt from the moon, which is full of silicon, and creating a 3-dimensional house. Excuse me. 3-dimensional habitat from the materials on the moon surface. And it's kind of interesting when you watch the video how it does it. Okay, but you're going to take the 4 silicone pieces found in the safe zone and transport them and deliver them to the silicone storage at Hayworth Crater. So if you notice, I dropped them. 3 of them went into the storage bin, 1 did not. So the point value for each one is a little different. It's a compounding kind of scoring. So if you get 1 in there, it's worth 5 points. 2 in it's worth 15. 3 it's worth 30. And all 4 it's worth 50 points. Okay, so you gotta deliver them to the silicon storage bin. The next one is Mine for Minerals. And this is the iron storage hopper. This is the reverse. There's 4 objects. You now have to have your robot, program your robot to take this lever and catch the iron. Recover the iron back to the safe zone. Okay? And again, the scoring for that is 5 for 1, 15 for 2, 30 for 3, and 50 for 4. Back in the safe zone. As long as you deliver them to the safe zone, partially, completely, you get the score. And folks, I had something last night for dinner that's not agreeing with me. So if you see me run, there's a good reason, because I'm about ready to run. So, the next mission is Shackleton delivery. So, what we're going to do is we're going to take our truck, which starts here with the cargo in the truck. Your team has to take the cargo and deliver the cargo to Shackleton Crater. All right? So notice how the cargo is in the truck, but they have to deliver the cargo to Shackleton Crater. Now Shackleton Crater, if you look at it, it has an outline. It's not a line like on the other mission, but there's an outline. So if you deliver the cargo to Shackleton Crater, you receive a score of 50 points. So the team has to find a way to get this over here. First off, in this location, it's outside the crater, no points. Partially in, it scores. Completely in, it scores for 50 points. But the team has to figure out a way to get the truck, to separate the cargo from it, and deliver the cargo to the crater. So it's the process that the kids have to go through. What are they going to do with this truck? Can they deliver the truck with the cargo? Yes. Can they separate it? Yes. The kids have to make up a plan of how to get the cargo out of the truck and to Shackleton Crater. If they're successful, again, it's 50 points. Now, where did I miss this one? Okay, I'm going to go back to the moon shuttle, because we're in that area right now. So what mission was it? Mission 3 or 4? So let's go over here to the moon shuttle. The kids get to program the robot, grab the moon shuttle, and notice how it's got a slide shoe on the bottom, which makes it unsteady. So the kids have to take the moon shuttle, and the worker, so to speak, is going to come over here to drive the truck. So the moon shuttle, the ring of the crater. Right now it's outside the ring of a Mudson crater, partially in, completely in, to get the score. Outside no score, partially in scores, completely in scores. Okay. The next one is the Mission 12 takeoff, and it's worth 50 points. So notice that the rocket, if you watch the video of rockets leaving Cape Canaveral, Vandenberg Air Force Base, and other locations, the rocket is vertical. Goes up, all right? But most of the time when it goes up, if it lands like a plane. Well, in order to go on the moon, we have to take the rocket and deliver it vertical to the landing zone. It has to be in the landing zone vertical with the presumption that the rocket is going to take off. So watch SpaceX videos. The Falcon 9 rocket routinely takes off vertical, and then the booster rocket comes back and lands vertical. The Super Heavy rocket comes back vertical, or leaves vertical, and they catch it. But it's positioned so that it can take back off. So if we're going to go to the moon, the rocket we send up there needs to be vertical. So here's the scoring for it. Outside of the ring, no score. Partially in the ring, score. Completely in the ring, score. If the rocket is on its side, no score. If the rocket is on its side, no score. The only way to get a score is for the rocket to be either partially or completely in the landing zone ring. And the score for that is 50 points. So, and then the last mission object we're going to discuss, again, you need to review the habitat, Mission 1 habitat document, because this explains a lot of what the kids have to do. But I'm going to turn this around. Well, the airlock door needs to be facing this direction. Okay, so the students need to leave the safe zone, come out, and act on the door. Okay, so it needs to be constructed in this direction. But I'm going to kind of show you, see how on the front edge of the airlock is even with the wall. Now your team can create walls. To receive points, they receive 25 points for Mission 1 if they show the referee and explain to the referee a habitat that is 1 story tall. If they show the referee and explain to the referee a habitat that is 2 or 3 stories tall, they get 50 points. So going back to the habitat document real quick, see how Sierra Space has got a habitat that is 3 stories tall. So if they can create a 3-dimensional, 3-story tall habitat, that is what I'm trying to get them to do. The living quarters, sleeping quarters, kitchen, activity room, you know, all kinds of things like that are going to be in the habitat. So this square needs to become a cube that the kids create a house for the astronauts to live. This is the airlock door that the team needs to act on during the match. All right, so let's go over the scoring. So first, they need to deliver the astronaut to the habitat. So somehow they create the habitat. They have to deliver the astronaut completely inside of the habitat they construct to get a score, and that's 35 points. If the astronaut is outside, they get no score. If the astronaut is partially, they get no score. The astronaut must be completely inside the habitat after delivery for 35 points. Put him over here. And remember, the astronaut, the team must bring their own minifig. So the tournament will not provide the minifig. Just make sure you bring that to the competition. Now, the airlock. This is kind of backwards, but this is what we're going to do. The airlock, when it starts, is in this position. And we're going to say that to close the airlock, the team has to push the airlock completely off the base. So in order to push that off, they'll get 35 points. So a combination of the astronaut and the airlock, they can get 70 points for this mission. But just know that the airlock, it fits in there, it slides real easy. At start, it'll be in that position, and you just need to program the robot to push it. Okay, so I'm going to put this back. And that pretty much concludes all the information for this year's challenge. Total point value is 800 points. Teachers have already given me some questions that I've answered in the documents that are presented to you today. But just know that if you have some additional questions, email me. It'll be the weekend many times before I can get back. And when you ask a question, the only fair thing to do is answer your question and provide that answer to all the teams, all the schools. So just know that if you ask me a question, I'm going to post it so that everybody has the ability to read it. So there will be a Q&A blog that I create for this that you can put the questions on, and you can visit and see what my response is. Other than that, again, we've got the t-shirts and other objects, the practice board that a lot of teachers have asked for. If you guys are interested in those objects, just go ahead and go to the website, click on the left column where it says Mission Horizon Challenge Supplies, and we can get you those supplies sent out. It does take about a week for me to get some stuff together. If you know some schools that are still interested, I do have some sets left. And also I'm looking for a couple regional sites, and I'm looking in Bowling Green right now for a regional site, and I believe that's it at the moment. My regional host from last year has gone on to a different position, so the Bowling Green, Kentucky area needs a regional host. The closest regional site to that area would be Owensboro, Louisville, or Paducah at this time, or they can compete in the virtual tournament. So I can ramble on for hours, but I know you don't want to listen to me because nobody else does, not even my kids. But just know that this completes the coaches meeting. There will be some additional training after the first of the year for referees. But other than that, if you have any questions, reach out to me and I'll get back with you as soon as I can. Thank you for watching. All right, bye-bye.